You ready? So, yesterday I talked about de Moivre's theorem, and this here is kind of de Moivre's theorem in reverse. So all you do with this, and doesn't that formula look intimidating? Does that formula look intimidating? Yes. So it's just kind of going backwards from what we did with it the other day. And so if you have, what did I just do? Oh, I want to go back. So what they say is find the complex roots of -1 plus 3x. So in other words, you took some number and you raised it to the third power, okay? Or if you took, so now you're cube rooting it, just like you would take the cube root of 27 or the cube root of 8 or the cube root of 125 or something like that. You would take the cube root of complex numbers. And the way you do that, just kind of like you did before, first you have to find R, okay? So who can tell me how I find R in this case? How do I find R? Just like you did on your quiz, you just took R is equal to the square root of what squared? -1 squared plus what squared? Root of 3 squared. Not I. I is kind of, it looks like it's inside the square root, but it's not. Okay? And so R is equal to the square root of 1 squared plus 3, right? Which is just 4, which is 2, right? Okay? And then you have to find theta. So you would take the inverse tangent of root of 3 over -1. And if you do that on your calculator or knowing the unit circle, that comes out to be -60 degrees or negative pi over 3 radians. But what this is a good rule to remember, okay? Since this angle, -1 root of 3, is in which quadrant? It's in the second quadrant, right? And -60 is in which quadrant? The fourth quadrant. So you have to add 180. This is what I wrote up here. If both x and y are negative, add 180, because inverse tangent will give you a negative angle. But really what you want is the angle that is in the third quadrant in this case, right? And in this case, if just x is negative, right, that means you're in the second quadrant, but taking the inverse tangent of that will give you an angle in the fourth quadrant. So again, you need to add 180 to it. You understand? Well, that's a good rule of thumb to remember. Anyway, so inverse tangent of that gives you negative 60 degrees. I'm going to add 180 to it, okay, plus 180, and I would get 120 degrees. So that is the angle for theta. So when you're finding complex cube roots, if you're finding the cube roots, you're going to have 3 answers. If you're finding the square roots, you're going to have 2 answers, and so should I just stop and give you guys like quiz on this or something? Because it seems like a lot of you just like reading books and playing with iPhones and stuff. No? I mean, if you know it already, and I don't think you do though, because this is one of the harder things that we do. All right. So in this case, we know that theta is going to be 120 degrees. So you plug into this formula. So you have 3 roots, and what they call is z sub 0 is the first root. Even though it's the first root, they call it z sub 0. And you take, for each case, this number here is going to be the same. And all that is the nth root of 2. So since r is 2, that number that goes in front is just the cube root of 2. And then you plug into this formula. Theta is 120 degrees, and n in this case is just 3, right? And then plus 2 pi k. K in the very first case, k is this number right here. So it's 2 times pi times 0, okay, over 3.
Wait, Mr. Reader, where'd you get K?
K is the number of the root that you're looking for. So even though this is the first, it's really the 0th root, okay? So the plus I sine of 120 divided by 3, 120 degrees divided by 3, plus 2 pi times 0 divided by 3. That's a times. Okay? Which when I simplify, okay, when I simplify that, there's actually should be a big parentheses around all of that. I get z sub 0 is equal to the cube root of 2 times, did I forget something? I forgot a cosine. I'm sorry. There should be a cosine in front of here, right in front of this angle. Cosine of 60. You guys see where I got 60 from? 120 divided by 3 plus 0. Plus I sine of 60, and that is the 0th root. That is one of the cube roots of negative 1 plus 3i.
Mr. Leader,
Yes,
120 divided by 3 is 4.
I knew that, Mia. I'm glad someone's awake. So that would be 40, and that would be 40. Okay? So the next one, z sub 1, all you have to do today, this formula gets very confusing. The radius is exactly the same. That number that's in front is always exactly the same. And all this says is you take this number and you add 2 pi times 1 divided by 3. Well, 2 pi times 1 divided by 3 is, yes? K is the number of the root. Okay, so because they say,
Yeah, why did you do the inverse statement of square root of negative 1?
because I have to, because this is the complex root in polar form, okay? So to get it into standard form, first it's in standard form, so I have to change it into polar form.
Right, okay.
And to find the angle, I have to take the inverse tangent of this over here.
Right.
That's it. But if x is negative, which it is in this case, I need to add 180. And then all you do with this, since there's 3 roots, hold on, you add 1/3 of 2 pi. Or in this case, I should have had this all in degrees, right? This should be in degrees. This should be 360 times 0 divided by 3. What's 360 divided by 3? 120. So you're going to take cosine of 40 plus 120, which is 160.
So you do 360 by 0.
No, because in the second case, this number turns into a 1. Okay? And in the third case, that number turns into 2. But the formula is very confusing. Just remember that all you have to do is add, if you're taking the cube root, if you're taking the cube root, all you have to do is add 1/3 of 360 each time. If you're taking the 4th root, you add 1/4 of 360 each time. If you're taking the 5th root, you add 1/5 of. So z sub 2, which is really the 3rd root, is going to be the same thing. 2, the cube root of 2, cosine of 160 plus 120, which is 280, right? 280 degrees plus I sine of 160 plus 120, which is also 280 degrees. And what that represents, let me just kind of draw a picture of what it represents. If this is your, if this is some point out here, -1, 3i, like up here, this is the radius, so what's a cube root of 2? I don't even know, 1 point something, right? So it means go out 1 point something and rotate through an angle in your imaginary plane of 40 degrees, okay? So say that point is right there. And then you take this and rotate through an angle of 160 degrees, which is over here somewhere. And then rotate through an angle of another 120 degrees past here, which puts you at 280, okay, a little bit past 270. And what you would actually get if you graph that, okay, is something that is each one of these, the length of this is cube root of 2, right? The length of each one of those is cube root of 2. And here's your first angle, which is 40. Here's your next angle, which is 160. And here's your next angle, which is 240. And you can see that they're equally spaced. You understand what I'm saying? So they're the same distance apart. Because if I add another 120 to it, I would be back here at 60, right? Because 120 plus this gives you 400, which is 60 degrees past 360. So that's the way you find the complexes. Did I confuse you, or are you okay? You trying to get it? First, you have to put it into r theta form. So I found r first, and then I take the cube root of that, and then I take whatever theta is, and I divide it by the number of roots I have. And then for the first one. And then for the second root, I add 1/3 of 360. And for the third root, I add 2/3 of 360, and then I'm done. Okay? And if they ask you to change it into standard form, what? If n equals 3, then now k is equal to, so k is n minus 1. So don't ask me why they do it that, just to make the formula work. So if you have 3 roots, the first k is going to be 2. Okay? Right, the first k is going to be, if you have 3 roots, then the first k is going to be 0. So it's 0, z sub 0. Z sub 0, z sub 1, z sub 2. And that's how you do it. So there's examples in the book. See if you can look at that and figure it out some more. But that's about the height of it. All right? Okay, we're done here. All right, stop this thing.